the length what the angle was, and that is the angle off of the wall that the thing came, that the blood came. So that's what we do with this pole. We once we know how high it was, we put a pole right around there. Then we find, remember these things, we find the angle that it came out. Here, that's what they did. They took this drop, they found the angle where that came from, and took this angle, and eventually, when you put all the angles together, they will converge in a more or less, in a place that's on the pole. That is the origin of the blood spatter. So they can tell how far away from the wall the person was, not just how high the blood was, the blood source was that we get from just finding they call the area of convergence. We also find the actual place in the room where the person was and where the blood originated. That's the string method. They take remember the length. Remember, divide the width by the length. Take the inverse sign. That'll tell you how far the angle off the wall that it was. Find all those angles off the wall. They'll converge in more or less one basic place on the pole that is set up right, so that it contains the height of the area of convergence. So you can figure out the volume of where it started. So you can tell where the victim was. By the way, you sometimes actually see this. If you'd ever see some crime shows where they try to find you see them putting strings all over the place. Now you know why they put strings all over the place. Anyway, so there's also gunshot spatter. It's a kind of impact spatter. Now, gunshot spatter, again, it's high velocity. It's going to create a lot of spatter. It goes both forward and back. Now, because it's high velocity, you're going to create tiny droplets, and it's going to look something like that. But gunshot spatter does actually create back spatter, and the blood splashes back right onto not just out of the victim as the bullet lets it goes through the victim, but it also spatters back at the attacker or at the source of the attack, and sometimes it can even get onto the gun muzzle and inside the gun muzzle where the criminal doesn't even know to clean it. So you can sometimes identify the perpetrator by looking at the gun and actually finding the blood inside the gun. However, these are small droplets. They don't travel far. It's usually only when the muzzle of the gun used to kill the victim or to shoot the victim is close to the victim. So again, back spatter is important, and you should pay attention to that and take a look for that if you can find it. Here's a case of it's actually happened. Stephen Scher claimed that he had a hunting buddy, Marty Dillon. He tripped and fell with his loaded shotgun, and he shot himself in the chest. And Stephen Scher claimed he said he had blood in his boots, but he said, I tried doing CPR. I really don't know if CPR will work on a gunshot to the chest, but he claimed he did CPR and got it on himself. But forensics, these blood spatter analysts, they said the blood spatter in Stephen Scher's boots was high velocity spatter. Tiny drops that gunshots make. That did not come from CPR wiping on his boots. So he was actually convicted of killing Marty Dillon based on this and one or two other things. Incidentally, he did something strange after. The reason why they actually suspected him was not they didn't really notice the high velocity spatter on his boots. They realized Stephen Scher actually went shortly after Marty Dillon died or was killed. He went and he married the widow of Marty Dillon. That raised a few eyebrows, and they investigated and they convicted him. Crime did not pay. There is also what they call cast-off spatter. That is when a baseball bat, something that hits, or even a fist, that hits the victim and causes blood. When it's drawn back for a second blow, the blood is thrown back in a noticeable pattern. And this is very often used. It's actually noticeable. It's very different from impact spatter. So they can say, I know that they used a pool cue. I know they used a baseball bat. And I know how many blows it was based on how the blood is propelled. So, and you can even identify the kind of weapon, more or less. A thinner weapon produces more smaller, and wider weapon produces bigger. Makes sense. You have more of the blood on more of a wider surface. It's going to create larger, blood drops or larger patterns. And it's also very important. You can use this to tell whether the criminal was left-handed or right-handed. And there was even a case, I think the Sam Shepard case, where the person said Sam Shepard could not have possibly done it. Sam Shepard was left-handed. The one who killed his wife was right-handed, so he was innocent. Well, anyway, this is very important, and cast-off spatter will tell these things. And you can tell the number of blows, at least the minimum number of blows. Like 3 cast-offs means there's at least 3 blows, usually 4th, because the first blow got the blood onto the weapon, and the 3 cast-off patterns were the 3 other times you hit him. So it's usually 4 times that if you have 3 cast-off spatter patterns. So this is like, it's sort of, this is a little more complicated, but here's a case that, let's say he hits something, the blood gets on it, then it goes back and it sprays off. This is like impact. Let's say he hits the impact, there's going to be forward spatter and also back spatter getting back onto the perpetrator over here. That's just a diagram. These are actual crime scene photos here's where a pipe was used, and you have the cast-off spatter, and it's thicker than when a pool cue was used to do the crime. So you can tell the difference, and you can tell what spatter is. You might notice that this is in a straight line or slightly curved line. If we'd look back at some of the other, like this is not in a curved line. That is definitely not back spatter. Definitely not cast-off spatter. So that was definitely not again. And let's see, other blood. Well, this is just a diagram. Again, it's certainly not cast-off. It's certainly not in a line or in a slight curve. So you can tell what cast-off spatter is, and you can tell that this guy was not killed by a gun, or at least this wound was not caused by a gun. It was caused by a blunt force weapon, let's say. Incidentally, you can use a knife too, and if you swing a knife, it'll also produce this, but they'll be even thinner than that of a pool cue because a knife is even thinner. Yeah, and certainly can tell. There's another example. You can certainly tell this is not cast-off spatter. Anyway, this is an arterial spray spatter that if an artery is slashed or cut, the blood from the heart's not going into the rest of the body. It's spurting out of this hole, and you find a large stain over here. It's like it blasted onto this. I think it's a pipe, and it eventually dripped down. So you can tell what arterial spray spatter is from this. And the heart doesn't just pump once. You might see a stain here, and you might see another blob over here, another large blob over here, another blob over here, and then another blob over here. It depends on where he might have moved. Like at first he was here, and then you can see a blob over here because he moved in this direction. You can tell some things by arterial spray spatter. And there's a large volume of it, and you can use this. It's a lot easier to get to identify because there's a lot more of the blood over here. And you can even show the movement. Often it is brighter red because the heart pumps to the lungs, but usually if you're going to cut an artery, that artery will be the artery that goes to the rest of the body. So